I am honored to have the opportunity to speak to you today about the topic of difference between two-sample T and ANOVA. This is a subject that holds great importance in the field of statistics. The objective of two-sample t-test is to conduct a hypothesis test of the difference between two population means when the samples are drawn independently from each other. Independent samples are measurements made on two different sets of items where the data in one group does not influence or relate to the data in the other group. In this specific example, the goal is to compare the daily sales for two different designs of web pages for an internet business. The two web page designs are represented by the two different images. The two-sample t-test allows you to determine if the difference in daily sales between the two web page designs is statistically significant. This can help the business owner make informed decisions about which web page design performs better in terms of driving sales. In this example, the gym trainer measured the body fat for a group of men and women who did workouts at a gym 2 times a week for 12 weeks. The two-sample t-test would be an appropriate statistical analysis to determine if there is a significant difference in the mean body fat reduction between the two groups.
Another example is comparison of patient satisfaction ratings of two hospitals. The two-sample t-test allows you to compare the means of two hospitals and determine if the difference observed is likely due to chance or if it represents a true difference in patient satisfaction. The slide outlines the key data considerations for conducting a two-sample t-test. A. The sample must be random. B. Sample data must be continuous. C. Sample data are from a normally distributed population. D. Independent samples. Measurements for one observation do not affect measurements for any other observation. These requirements are important to ensure the validity and reliability of the statistical analysis. Specifically, random sampling ensures the sample is representative of the overall population. Continuous data allows for more precise statistical comparisons. Normally distributed data meets the assumptions of the t-test. Independent samples means the measurements for one observation do not influence the measurements for any other observation. Violating these assumptions could lead to biased or invalid results from the two-sample t-test. It's crucial to carefully evaluate the data and ensure it meets these criteria before proceeding with the statistical analysis.
The page provided shows an example of a software evaluation project where the researcher hopes to demonstrate that the new software package will provide a shorter mean project completion time compared to the current software. The data is presented in two columns, current software and new software, with various project completion times listed for each. This appears to be the data the researcher will use to conduct two-sample t-test, to determine if there is a significant difference in the mean project completion times between the current and new software. Based on the descriptive statistics, the mean for the new software, 262.4, is lower than the mean for the current software, 335.1. In summary, the two-sample t-test results suggest that the new software has a significantly shorter mean project completion time compared to the current software. The null hypothesis states that the difference of completion time between the two software is 0. Because the p-value is 0.000, which is less than the significance level of 0.05, we reject the null hypothesis and concludes that the project's completion time for the two software differ. The two-sample t-test is used to compare the means of two different populations. How can we compare the means for more than two populations? We use ANOVA, analysis of variance. Analysis of variance is an extension of the two-sample t-test. To perform an analysis of variance, you must have a continuous response variable and at least one categorical factor with two or more levels. One-way analysis of variance is a statistical method used to determine if there are any statistically significant differences between the means of 3 or more independent groups. For example, the manager of metal industry would like to determine if any of 5 different processes for assembling components results in higher productivity per hour and/or in fewer defective components.
The null hypothesis states that all the population means are equal. The alternative hypothesis states that at least two of the population means are not equal. If the test results in a statistically significant difference, the null hypothesis is rejected, and it can be concluded that at least two of the population means are not equal. If the test is not statistically significant, the null hypothesis is not rejected, and there is not enough evidence to conclude that the population means differ. Analysis of variance table. The F ratio in ANOVA compares between group to within group variance. indicating the presence of significant differences. A significant F ratio suggests notable variance between groups, pointing to potential differences in mean values. In ANOVA, we compare between group variation to within group variation to determine between groups exist. If the between group variation is small relative to the within group variation, there is little evidence that the population means differ. On the other hand, if the between group variation is large relative to the within group variation, evidence suggests that the population means are not the same.
Variation within each group refers to the differences or variability among the data points within each individual group. For example, in the first group, the values are 29, 30, and 31, showing some variation within that group. Variation between groups refers to the differences or variability in the mean values across the different groups. For example, the mean values for the three groups are 29.75, 29.5, and 27.25, indicating there is some variation between the groups.
In analysis of variance, ANOVA, the total sum of squares helps express the total variation that can be attributed to various factors. The total variation, SST, is the sum of the variation between the treatment groups, SSB, and the variation within the treatment groups, SSE.
T is the total sum of squares of differences of each observation from the overall mean. SSB is sum of squares of differences between each subgroup mean and the overall mean. SSE is sum of squares of differences between each observation from its subgroup mean. The ANOVA table helps researchers determine whether the differences observed between the group means are statistically significant, which is crucial for drawing valid conclusions from the experimental data. By analyzing the F value and the corresponding P value, researchers can assess the impact of the independent variables on the dependent variable and make informed decisions about the significance of the findings. Let's take an example. To study the effect of temperature on yield in a chemical process, 10 batches were produced at each of 3 temperature levels. The results follow. Construct an analysis of variance table. Use a 0.05 level of significance to test whether the temperature level has an effect on the mean yield of the process. The p-value is a measure of the strength of the evidence in your data against null hypothesis. When the p-value for the factor is less than the significance level of 0.05, it indicates that there is strong evidence to reject the null hypothesis. This result suggests that the group means are statistically different from each other. Difference between two-sample t and analysis of variance. Two-sample t test is used to compare the means of two independent populations or groups. In this case, the goal is to compare the daily sales for two different designs of web pages for an internet business. Analysis of variance is used to compare the means of more than two independent populations or groups. In this case, the goal is to compare the drying times of 4 different paints. In summary, two-sample t-test is hypothesis test of the difference between two population means when samples are drawn independently from each other. One-way ANOVA or analysis of variance is an extension of the two-sample t-test. To perform an analysis of variance, you must have a continuous response variable and at least one categorical factor with 2 or more levels.